Hello, this is day 5 from Unit 4, which is Chapter 3B, on the nature of graphs. And what day 5 is really kind of just putting it all together, similar to the last two problems in examples from day 4, from the day 4 video. So it's combining, as it says at the top. We'll check out the extrema, the end behavior, and the increasing and decreasing intervals. So all three of those. All right, so I'll just do a couple examples. So you want to put this into Desmos so you can get a picture of it. And I already did that. Let's check to see I put it in right. X third, 3x squared minus 2x plus 1. Okay. And Desmos is awesome. So we can check out our critical points. Our extrema, really. Critical points would include both the intercepts, but we're not too concerned about that at this moment. And so this is a typical standard x to the third graph, or odd function. Has the same end behavior as all odd functions, where the left tail end of the graph goes to negative infinity and the right tail end of the graph goes to positive infinity. So it's easy enough to start there, and maybe we'll just copy this right now. Old graph, new graph. A little large. Yay. All right. So this is everything we need. We just need to be able to know the notation and classify things correctly. So the end behavior I like to start with because it's the easiest, and we don't even need to look at the graph. We just need to look at that part. Leading coefficient is positive, so it's going to be normal, characteristic of all odd functions, and it's an odd function. So this is part C. So I will say that as x approaches negative infinity, so left tail end of the graph as we go marching out in the negative x direction, the function f of x approaches negative infinity in the y direction. As x approaches positive infinity, my graph approaches positive infinity in the y direction. Okay, so we got that one. We also graphed it on Desmos. We can name and classify the extrema. Part B. We see that where we'd be thinking of extrema, there's 4 possibilities. There's an absolute maximum, absolute minimum, relative maximum, relative minimum. There's no absolutes because this graph goes in both directions to negative infinity and positive infinity, so there's no absolute max or min. Relatives. Rel max is like a peak in the graph, and we see that it bounces up to this point and then turns around, goes down here to that point, and goes up. So it's a peak, and it is at negative 0.6162.202. And rel minimum is the valley. So it's the other critical point that is the dip, 0.216 and 0.758. Gosh, we should be really happy for Desmos right about now. It has done everything for us. And really, I think the trickiest part, put it in red for tricky, I guess. The trickiest part is the intervals for increasing and decreasing. And the only reason why is just because interval notation may be newer for us. So I will say, increasing or decreasing doesn't matter which we put first. It looks like as we go from left to right, our graph is going up. And so that means starting at negative infinity, you can say that you start there, it goes up to the extrema, the relative extrema of negative 0.616. And that is a definite number, so we put a bracket there. And next, it's going down again, or for the first time, so it's going decreasing from this point to this point. So we have the points already, and it's decreasing, so that's the decreasing part, from left to right. So definite point, negative 0.616, and it stops decreasing at 0.216. Again, bracket because it's a definite point. And then it starts increasing again at that where it stopped decreasing. So there's a union of this other increasing portion, 0.216, and then up to positive infinity with the parentheses. We did so that's how you would, in a typical problem, you could pull all this information out just from, well, graphing on Desmos to have it help you. If you need further explanation, this is from days, again, 3 and 4. The end behaviors from day 3, and then day 4 has the extrema, the maximins, and then the increasing, decreasing. More problems below. I really think we should probably check out number 5. Things will get a little weird. 10 over 3x squared plus 5. And we have something a little odd. We could zoom out a little bit if it helps us look, and it looks as if this graph just goes forever in both directions, left or right, and it does not really go below the x-axis even, and it doesn't go very much above the x-axis. So let's zoom back in and just kind of see. All right. We can take a little picture. Okay, so here's our picture. We want all the attributes, and this will be somewhat different. A, which gets the graph on Desmos. Boom. B, extrema. There is actually an absolute maximum. This is the highest the graph goes, is right there. So for part B, we have an abs max at 0, 2. And we can't really say we have any particular point that is the minimum. We can say a couple things like it in both directions, the negative x and the positive x. It's going forever in the x direction, but in terms of where it goes, and this is more like end behavior, it's going closer and closer and closer to 0 in the y direction. It's getting closer to the x-axis, which in terms of the y direction is 0. We don't have any other relative mins or max, so we're done with the extrema. It just has an absolute max. And so our end behavior is going to be a little slightly different. As x approaches negative infinity, what is our function doing? And as x approaches positive infinity, what is our function doing? Function, as we go marching out to the left on the x-axis in the negative direction, our graph gets closer and closer and closer and closer and closer and closer and closer to 0 as a height. Like in the y direction, it gets closer and closer to 0. So we would say f of x gets closer to 0. And oftentimes, we may not see this, or we may. If it's getting closer to 0, we kind of want to delineate which side of 0, because I could be really close to 0 right there, or really close to 0 right there. And so to specify which side, we just put a little plus right there. It's the positive side of 0, meaning that it's approaching it from larger positive numbers, and it's approaching 0. Similarly, as x approaches infinity, marching to the right, our function is getting closer and closer to 0, again, on the positive side. It would be down here if it were approaching 0 on the negative side. Okay, that's end behavior. And intervals of increasing and decreasing. So I don't have a ton of space. Let's do it in red. Increasing, decreasing. As we are way out on the left as we start marching, if we read the graph left to right, we see that the graph is going up ever so slightly until we get up to its absolute maximum. And so it is increasing from negative infinity to 0. And then once it hits that maximum, it starts decreasing, and then, kind of a lot right away, but then increasingly smaller changes of how fast it's decreasing, and it just keeps on getting infinitesimally closer to 0 on the positive side. So we would say it's decreasing just in the x direction, starting at 0, and it goes to infinity. So there is no unions here. It only has one change in whether it's increasing or decreasing, and that's at the 1 extrema. All right, hope this video gives you a good jump start to the lesson. Again, if this was confusing, this is just a review from days 3 and 4. Good luck.